It's hard to believe, but some of America's biggest geological warnings aren't on the coasts. Deep beneath Kentucky's calm hills and quiet rivers, the ground may not be as still as it seems.
The Kentucky River, as Chris said, still rising in the Frankfort area. It is not expected to crest until at least Thursday.
Officials are worried neighborhoods will be underwater by then.
It's hard to believe, but some of the most important geological warnings in the United States are not on the coasts. They are in the quiet, green interior of the continent. Kentucky, a state known for horse farms, rolling hills, bourbon and river valleys, seems peaceful, calm, unmoving. But beneath its forests, highways, farmlands and karst caves, the land is not still. In 2025, scientists noticed something extraordinary. The same deep tectonic signals detected under Puerto Rico, Cascadia, the Appalachians, Yellowstone and the Great Basin are converging in Kentucky. Because Kentucky sits at a crossroads of the continent's stress highway, the invisible network through which pressure redistributes as North America slowly adjusts, and the ground is beginning to whisper again. Chapter 1. The Pulse Beneath the Bluegrass. The story begins deep below central Kentucky, beneath the limestone hills and open pastures of the Bluegrass region. Here lies one of the most complex geological structures in North America, a vast system of fractures, karst channels, and deep basement faults. For decades, the land barely moved, stable, predictable. But in early 2025, seismometers recorded a low-frequency tremor, deep, slow, rhythmic, repeating over days. Not an earthquake, not fracking, not mining, a mantle-level signal. The same harmonic pulse detected after the Puerto Rico Trench slow slip event. Kentucky responded, like a drumhead vibrating to a distant strike. And though nothing moved on the surface, the baseline changed. The continent had begun to speak inward. Chapter 2. Mammoth Cave. The system that breathes. Beneath south-central Kentucky lies the largest cave system on Earth, Mammoth Cave, a cathedral carved not by hands but by time, acidic water, and continental memory. More than 426 miles of mapped passageways, and likely just a fraction of what truly extends below. This is not just a cave, it is a pressure network, a living hydrological machine connected to the deep crust. For centuries, the groundwater in the region followed a predictable script. Rain infiltrates limestone, dissolves pathways, drains toward the Green River system. But in 2025, something impossible happened. The water flow reversed direction in parts of the cave. Not from storms, not from flooding, not from drought, but from subtle pressure change in the basement rock beneath Kentucky. Sensors in underground streams recorded a shift in flow speed not tied to surface rain cycles, elevated mineral concentrations from deeper geologic layers, warmth in water emerging from previously cold channels. Then came the atmospheric changes underground. CO2 concentrations rose, not gradually, but in pulses. Micro cracks appeared along ceilings in deep chambers, far below any human influence. Acoustic monitoring detected sub-audible vibrations like a slow heartbeat. The cave system was not collapsing, it was exhaling. Because Mammoth Cave is not just a void, it is a pressure gauge. Throughout Earth's history, cave systems have reacted before major tectonic reorganizations, before continents collided, before rift valleys opened, before mountain roots rose again from deep crustal flow. Caves respond first, because they are the lungs of the land, the first structures to register pressure redistribution within the crust, and Mammoth Cave is feeling something large. Further mapping revealed inactive channels flooding for the first time in thousands of years, while long-running flows dropped silently, leaving behind exposed cavern floors polished smooth by ancient water. It is as if the cave is rerouting its own circulation, like a body adjusting blood flow under stress. No explosions, no collapses, no alarm, just reorganization. Quiet, deliberate, coordinated. And the most telling detail? The timing matches exactly with the Puerto Rico Trench slow slip event. The same pulse recorded in the Appalachians, in the Mississippi River Basin, and deep beneath Yellowstone. The cave is not reacting randomly. It is listening to the continent, and the continent is breathing.
Chapter 3.
The Appalachian Signal. To the east, Kentucky touches the Appalachian Mountains, a ridge of forested folds so old they have outlived oceans, supercontinents, and entire ecosystems. Most see them as permanent, ancient, finished, but mountains are not monuments. They are scars, and scars remember. In 2025, precision satellite interferometry, instruments capable of detecting motion smaller than a human hair, picked up something unexpected across the Cumberland Plateau. Uplift. Not meters, not centimeters, but millimeters. Rising in a coherent, organized pattern across hundreds of miles. And the timing was exact. The uplift synchronized with the 37-day slow slip event beneath the Puerto Rico Trench. Harmonic tremor pulses beneath the Atlantic margin. Deep crustal pressure migration toward New Madrid. This was not noise, not weather, not groundwater. It was crustal response. The Appalachians flexed, not violently, not destructively, but deliberately, as if the mountain belt were adjusting its weight, shifting like a sleeping animal, rolling to a new position. This movement is not supposed to happen. For 300 million years, geologists believed the Appalachian route was fossilized, locked, rigid, cold, unreactive, a relic of the ancient collision that built Pangaea. But the 2025 signal says otherwise. Within deep crustal rocks beneath Kentucky's eastern ridges, magnetotelluric measurements detected increasing conductivity. Quartz grains in metamorphic belts rotated microscopically. Seismic wave velocities changed, indicating fluid redistribution at depth. In plain language, something moved below the mountain roots. This means the Appalachians are not geologically dead. They are connected to the trench offshore, to the Mississippi Basin, to the mantle plume fields below Yellowstone, and to the slow rebalancing of the Atlantic plate. The mountains heard the signal from the ocean floor and answered. This has never been recorded in modern scientific history. If an ancient mountain range can still move, still breathe, still respond to pressure, then the eastern half of the United States is not stable. It is alive. And if the Appalachians are capable of movement, the question becomes, what exactly are they preparing to respond to next?
Chapter 4.
The river that remembers. Kentucky is shaped by rivers. The Ohio, the Cumberland, the Kentucky River, the Green. To most people, these waterways are landscapes of calm, fishing banks, ferry crossings, quiet bends where fog clings low in the morning. But rivers are more than water. They are records, and sometimes warnings, because rivers do not just flow across the land. They follow it. They trace the shape of the crust beneath. They bend where the land bends, fracture where the rock fractures, rise when the ground swells, and fall when the earth exhales. Which is why what happened in late 2025 stunned researchers. When sonar mapping teams from the US Geological Survey surveyed the underwater channels of the Ohio River, they found fresh microfractures in the riverbed. Not eroded, not weathered, sharp, new, clean, as if the rock had been pulled, not broken. And all of the fractures pointed southeast, the exact same vector traced from the Puerto Rico Trench slow slip pulse. Then the same pattern appeared in the Cumberland, then in the Green River Basin, then in the network of tributary streams that feed the Mississippi. This was not erosion, not flooding, not sediment movement. This was alignment. At the same time, satellite-based altimetry detected riverbanks shifting outward by millimeters, wetlands and backwater swamps filling from below, not above, deep meander loops migrating sideways, without flood events to drive the movement. This means the land beneath Kentucky did not just move vertically, it tilted, subtle, slow, coherent. Because rivers are the first to respond when the crust changes shape. They are the surface expression of deep pressure migration. And right now, the rivers are not merely flowing, they are remembering. They are tracing the same tectonic whisper traveling across the continent. Puerto Rico to Appalachians, to Kentucky, to Mississippi Valley, to Cascadia, to Yellowstone. The rivers are telling the truth before the land speaks loudly. And the truth is simple. The continent is adjusting, quietly, patiently, deliberately. And the rivers are whispering again, because they have seen this before.
Chapter 5.
The New Madrid Shadow. To the west lies the New Madrid seismic zone, a place that looks quiet, just farmland, river bluffs and small towns along the Mississippi. But beneath that stillness sits one of the most unpredictable fault networks in North America. In the winter of 1811 to 1812, this region unleashed a sequence of earthquakes, so powerful that church bells rang in Boston, sidewalks cracked in Washington, D.C., forests sank into the ground, and the Mississippi River ran backward, forced upstream by shock waves rising from deep inside the earth. For over 2 centuries, we assumed those scars had healed, but they did not. They waited. Kentucky sits directly within the stress transfer corridor of this system, the invisible pathway through which pressure travels from the mantle transition zone upward into the crust. And in 2025, New Madrid began to stir again, not with shaking, not with destruction, but with deep signals, mantle tremors, vibrations originating far below the crust, fault reopening signatures, tiny separations, measurable only by high-precision GPS, crustal stress migrating east, toward Kentucky's limestone and carbonate platform. This is not random movement, this is realignment. As pressure redistributed across the continent following the Puerto Rico Trench slow slip, the Mississippi Valley began to respond. Not explosively, not rapidly, but deliberately, like a door quietly unlocking. Then came the most telling clue. A lateral shift in deep groundwater levels across western Kentucky and Missouri. Water wells rose and fell in a perfectly synchronized wave, one that could not be explained by rainfall, drought, or pumping. Only pressure change at depth creates that pattern. New Madrid is not waking up to repeat the past. It is realigning, adjusting its internal geometry to accommodate a continent-wide redistribution of stress. This is not a countdown. This is a preparation. The Earth is not warning, it is organizing. And Kentucky is not merely near this process, it is inside it.
Chapter 6.
The karst that collapses without warning. Kentucky contains one of the most extensive karst landscapes in North America, formed primarily within Mississippian-age limestone. This landscape is characterized by solutional voids, subsurface drainage networks, sinkholes, disappearing streams, and large cave systems. Because karst terrains rely on structural support distributed through both solid rock and open voids, they are highly sensitive to changes in subsurface stress and groundwater conditions. During 2025, Researchers documented an increase in sinkhole formation rates across several counties in central and western Kentucky. Notably, these sinkholes did not correlate with typical triggering factors such as heavy precipitation events, flood recharge cycles, construction or mining activities, changes in surface land use. Instead, the increase in collapses was observed along a linear corridor trending southeast-northwest, corresponding with a known inland stress transfer pathway that links the Atlantic passive margin to the Mississippi embayment and New Madrid seismic zone. Subsurface monitoring indicated the following accompanying changes: groundwater flow direction shifts in confined karst aquifers, localized reductions in hydrostatic support within void-bearing limestone units, increased CO2 concentration and water aggressiveness, suggesting enhanced dissolution potential, microfracturing detected via acoustic emission surveys, particularly at depths not influenced by seasonal surface processes. These findings suggest that the karst system is responding to changes in crustal stress gradients rather than surface weathering conditions. Small alterations in stress or pressure can modify groundwater pathways, enlarge pre-existing voids, and lower the mechanical stability of overlying sediments. This process does not necessarily produce detectable seismic activity. Karst collapse can occur silently, without precursor microearthquakes, because the controlling mechanism is roof failure over expanding voids, not tectonic rupture. From a geomechanical perspective, the increase in collapses reflects subsurface void space expansion and reorganization, rather than surface erosion. This indicates that portions of Kentucky's limestone platform are undergoing gradual internal adjustment in response to regional stress redistribution.
Chapter 7. The Ohio Valley Tilt. The Ohio River Valley represents a structural transition zone between the Appalachian Foreland Basin to the east and the Mississippi embayment to the west. Historically, this region has been considered tectonically stable on human timescales, with only gradual isostatic adjustment expected following the last glacial retreat. However, data collected in 2025 from a network of high-precision GNSS, Global Navigation Satellite Systems, and INSAR, Interferometric Synthetic, aperture radar stations, revealed a persistent differential vertical motion across Kentucky. The western portion of the state, including the Jackson Purchase region and areas approaching the Mississippi embayment, is undergoing slight subsidence on the order of 0.5 to 1.8 millimeters per year. The eastern and south-central regions, particularly along the Cumberland Plateau and foothills of the Appalachians, show corresponding uplift of 0.7 to 2.3 millimeters per year. Although these displacement values are small, their spatial coherence and persistence over multiple measurement cycles indicate that they are not random artifacts or seasonal effects. Instead, they appear to reflect regional stress redistribution occurring at crustal depth. Supporting observations include gravimetric surveys suggest a shift in mass distribution associated with deep lithospheric adjustment. Borehole strain meters in eastern Kentucky recorded periodic microstrain consistent with compressional loading. Hydrological head pressure in confined aquifers changed in synchrony with vertical displacement, suggesting coupled crustal deformation and groundwater response. This pattern of uplift and subsidence aligns directionally with a stress propagation vector originating from the Puerto Rico Trench slow slip event, continuing through the Appalachian root zone and extending into the New Madrid seismic zone. The spatial continuity of this signal across multiple geological provinces implies continental-scale stress transmission rather than isolated regional phenomena. In geodynamic terms, the Ohio Valley is functioning as a flexural hinge, a transitional region where the lithosphere adjusts in response to loading and unloading elsewhere along the plate. This condition reflects coordination rather than coincidence. The vertical motions recorded in 2025 therefore represent part of a larger, integrated continental response to deep mantle and plate margin processes. Chapter 8. The fault beneath the Bluegrass Parkway. Beneath portions of central Kentucky, including the region traversed by the Bluegrass Parkway, lies a series of deeply buried basement faults associated with the structural boundary between the Lexington Platform and the Illinois Basin. These faults formed during Paleozoic tectonic events and have traditionally been regarded as inactive, with no significant seismic expression in the modern era. For decades, they were treated as structural features of historical interest, rather than active components of present-day crustal mechanics. What makes this finding significant is not the magnitude of the movement, but the context in which it is occurring. The direction of deformation aligns with a broader regional stress transfer pathway extending from the Puerto Rico Trench through the Appalachian lithospheric route, across central Kentucky, and into the new Madrid seismic zone. The reactivation of the Bluegrass fault system appears therefore to be part of a continent-scale stress reorganization, rather than a localized anomaly. This fault is not driving the process, it is responding to it. The lithosphere beneath Kentucky is not geologically dormant, but actively adjusting to changing conditions within the North American plate. It is not shaking, it is whispering, listening. Chapter 9. The land that moves without sound. Stand in Kentucky, on a farm road, in a forest hollow, on a limestone ridge, and the world feels still. Solid, ancient, permanent. But beneath the quiet landscape, the continent is alive, not in chaos, not in catastrophe, in coordination. Kentucky is where that coordination becomes visible first. The ground is rebalancing, the rivers are realigning, the caves are breathing. The continent is preparing for its next long chapter. Not disaster, adjustment. And we are living in the first pages of that change. If you want the next update as the signals continue, subscribe. Before you scroll, answer this in the comments. Silent Earth or Speaking Earth? Which one do you think we're standing on right now?